Hi, everyone, and welcome to episode 3 of Cosmos Crusaders. So, before we get into our episode this week and introduce our guest, you may notice that I am in a different location that has not been seen before by you guys. So, this is actually my home in San Ramon in the Bay Area. I came back for the summer because I just finished my first year of graduate school in my PhD program at the University of Maryland. So, just talking a little bit about sort of how that went. Um, Starting my PhD in astronomy was a lot of what I expected and some things which I didn't expect. Um, it was definitely a lot of learning experiences. And the one thing that really stood out to me about my experience in my first year was how important my cohort was to me and the group of people that were around me. I was really grateful to have such a really good group of friends that were able to help me get through situations in my first year that were difficult. Your first year of graduate school is a lot of stuff being juggled at one time, especially being a TA, starting with your graduate classes and starting with research at the same time, along with a lot of other stuff that I was doing in the department. And another thing that I did that I didn't expect to do was start this podcast, but now we're already on episode 3 and continuing on as we get into the future. We have some more really exciting guests lined up, which we will announce in the coming weeks. And yeah, so I guess just that was just a little bit of a recap of my first year. I'm gonna be here throughout the summer, except for our next episode, which will be a little bit different, but we'll announce that soon in the coming days. So yeah, that was just a little bit about my first year at UMD.
Well, we're all very proud of you for finishing your first year, and I hope the rest goes by smoothly and quickly. And I know that you're going to continue to do great work. And yeah, before we go into our actual interview, we're going to talk a little bit about our guest, Kishalay Day, a postdoc at MIT, and kind of talk about the parts of his interview that stood out the most to us. But Kishalay was our first postdoc that we've had on Cosmos Crusaders, and it was honestly such a great time having him. I personally haven't been able to meet him before this, and Gokul always talks very highly of him, and he lived up to all of my expectations. Kisha is very intelligent, and I think that the way that he sort of explains his research through anecdotes and in terms that I can understand made it clear that he's a great mentor and will be a great professor as he continues on this journey throughout his research and as he pursues like more positions in academia. Um, Keishley talks a lot about what Gokul mentioned about how community and your cohort is a really important part of grad school and how they help you through the adjustment period and how you can study and do all your classwork as well as work in the department with them. And he also mentions that as an international student coming from doing his undergrad at the Indian Institute of Science, um, he had a big community of other international students as well as his advisor, Mansi Kasliwal. She was also Gokul's advisor at Caltech, and they share the same Indian background, and that helped him a lot throughout his adjustment period when he went to Caltech for grad school. I don't know, Gok, if you have anything you want to add to that or talk about a different part of the interview.
No, yeah, I think that sums it up really well. He talks a lot about community and his culture, coming from an Indian background. And I think it's cool that we're also dropping this episode at the end of AAPI month, which is exactly on this Tuesday, May 31st. So yeah, there were a lot of really, really interesting parts of the interview, a lot of things that I learned about Kishalay, about both his science and his personal career that were really helpful. And some things that I'll personally take away are the things that he said about how he sort of views mentoring students and sort of what he's learned over the years because he's already mentored quite a few undergrad students, one of them being me during his time at Caltech. Kishley started research from a very young age, right at the beginning of his undergrad. because he had the opportunity to do so at the Indian Institute of Science. And I could sort of just tell how he cultivated all of his research experiences through his undergrad and graduate career, and has sort of built a bit of a roadmap for himself on how to best mentor students. And I think that we definitely need more people like him in the field who have such a passion for mentoring the next generation of scientists, because the field needs more people that sort of give an emphasis to that aspect of the job, in my opinion. It's not just all research, it's also the impact that you have in influencing the next generation, which ultimately will provide better research for the community, because the more scientists that we have that are able to be supported in healthy ways is just going to be able to affect the way that they do their research in better ways. So yeah, that was one thing that I really took away from the interview. But yeah, so I think that's a bit of an introduction to this week's episode, and now we can get into our interview with Kishalay. So we hope you guys enjoy it. We're very excited to have our first postdoc on the show, and it is extremely our pleasure to introduce Dr. Kishalay Day. So Kishalay got his bachelor's in physics from the Indian Institute of Science in Bangalore in 2016. He graduated with a PhD in astrophysics from Caltech in 2021 with his thesis titled The Whisper and the Bang, Cosmic Fireworks in the Lives of Compact Binaries, under the supervision of Professor Mansi Kasliwal. At Caltech, he won the Milton and Francis Clouser Doctoral Prize, which, according to the website, is the thesis with the greatest degree of originality, ingenuity, and potential for opening up new avenues of human thought. And this is with all of the Caltech graduate students in all fields. So this is a very big accomplishment. He is currently a NASA Einstein Fellow at MIT, and he also recently won the Best Dissertation Award at the High Energy Astrophysics Division meeting in Pittsburgh in March. So he is a very accomplished scientist already in his young career. And me and Kishalay have a relationship through, he was actually my research mentor when I was at Caltech, because my advisor was Professor Mansi Kasliwal, and that was Kishalay's PhD advisor as well. So Kishalay is an amazing scientist and an amazing mentor and person, and we're extremely excited to have him on Cosmos Crusaders. And he's originally from Kolkata, India. So yeah, that was a brief introduction of the many accomplishments that Kishalay has had in his career so far. So welcome to the show.
Yes, thank you for having me. Yeah, and thank you for that very generous introduction.
Yeah, definitely. So I'm very excited for this episode because I want to learn more about Kishalay, not only from a scientific point of view, but also sort of from a personal point of view and sort of what drives him, because in a sense, he is one of my role models in the field, because I look at you and all you've accomplished, and especially all the mentoring stuff and how good of a mentor you are. And I definitely want to get to that level one day. So we're going to start out with how we usually start out with in the show, talking about your research. So I know that you were always working on a multitude of projects at Caltech, which encompassed a wide range, including instrumentation on near-infrared surveys, studying faint supernova explosions, understanding stellar binaries, and much more. And I'm sure that you're still working on many of these areas at MIT. So the first question I wanted to ask you is something I've been wondering about for a while when it comes to your research. What are the highest level questions that you're trying to understand through your research that sort of ties all the projects that you're working on together, even in the loosest sense?
Yeah, okay, that's a super interesting question. I could probably talk for hours about what really motivates me, but I'll try to keep it short. But yeah, so I think you already mentioned sort of the broad theme of my research, but I think to put it, in a nutshell, the broad theme of my research are stars that are in binaries. So it turns out that our sun is a normal star, but it was more or less born in isolation, in the sense that we don't know of any companion to the sun, that that another star that's orbiting the sun, that's held together by the gravity of the sun. So it's an isolated star, and it's not, well, it's isolated star, but it has planets around it, and we live on one of those planets. But it turns out that that's not the norm for a lot of stars. Most stars in the universe are actually born not in isolation, but they're born as part of families. These are stars that are, some of them are born in binaries, which means that there are two balls of gas that are orbiting each other because of their mutual gravity. And some, we think that many of these stars are actually born in systems that have more than two stars, 3 stars, 4 stars. We know of a lot of this phenomenon. And it turns out that the reason why we see so much of diversity, even if you look around you, there's so many elements in the periodic table, the carbon in your skin, the iron in your blood. A lot of this diversity comes from the fact that that many of these stars are born as binaries, and they go through phenomena that normal isolated stars don't go through. So, if you took a star like the sun in isolation, if you told me what its mass was, told me what its composition was, it's relatively straightforward to predict how the star would evolve over its life. It starts burning hydrogen into helium, which is what we think most stars do for most of their lives. And then as it grows older and older, it starts burning to progressively heavier and heavier elements like oxygen and carbon and the stuff that you see in the periodic table. So, and by the end of its life, we know that the sun will actually end up as a dead remnant known as a white dwarf, which are these extremely dense regions of material where you essentially have about half the mass of the sun compressed into something that's about the size of the Earth. And most stars in the universe would end up like that. And it's relatively straightforward to predict how this would happen. The fun comes when you put two stars that are not in isolation, but are actually around something else. And by around something else, I mean in a situation where as the star goes through its life, you can't ignore the effect of the companion, in the sense that at some point the star is going to start interacting with its companion as it grows older and starts transferring mass to the companion. And when that happens, that's when the fun begins, because then you also have to take into account how far the companion is, what type of star the companion is, what is, where is the companion in its life, and so on. And a lot of the diversity in terms of the stuff that we see around us comes from the fact that most stars are actually born in binaries. And that's really the focus of my research. I try to really focus on the phenomena that are actually somewhat the most poorly understood in the lives of these binaries, which are the brief episodes of interaction between these stars, in the sense that for very brief periods in the life of these stars, these two stars start talking to each other. One star transfers mass from itself to the other companion and vice versa. And when all of this happens, that's when you start seeing a lot of the explosive phenomena that we see in the sky. Things like supernovae, things like when these two stars merge, if they end up merging at some point, they produce transient phenomena of the kinds that we can see definitely in nearby galaxies and even in our own galaxy. And that's really been the focus of my research, which is, can we find enough number of explosive events in the sky coming from these binary stars that we can actually end up creating a roadmap to say that, hey, if you start with two stars that started off at being so far apart, and they started off with so and so mass, can I use these transient phenomena to essentially create a roadmap going from, here is how you started this, and this is what it ended up as, and this is what it ended up producing over that entire period while the stars were interacting with each other. So yeah. Yes, and in that process, I obviously I try to develop the tools that are required to do that. I think you mentioned that I've been involved with instrumentation. It turns out that a lot of these questions are kind of hard to answer without using new forms of instrumentation, because some of these questions require those kinds of efforts. And that's really been the sort of motivation for me, which is that I want to answer these questions, but if you need new instrumentation to answer these questions, I'm happy to help build those new instruments as well. So that I really enjoy that part of being in astronomy, which is that I get to sort of not only learn the science, but also really know where the data comes from, what kind of instruments the data comes from. And I think that's been quite an enriching experience.
Yeah, that's amazing to hear. Very, very good summary of the many things you do. One of those instruments is the Palomar-Gattini survey, which you were an integral part of, and was a big part of my time at Caltech. So I guess if that wasn't implemented by you, then I feel like I would be in a very different place right now. So thank you for all your help with that as well.
No, thank you for doing such amazing work with the instrument as well.
Yeah, thank you. So now sort of transitioning to what you're working on specifically now. Professor Kasliwal mentioned to us on a Gattini call last year that you'll be transitioning to working on more compact object science in MIT. And your bio says that on the MIT website says that you're working on systematic searches for neutron stars and black holes in the galaxy now, which to me seems like a little bit of a transition from the stuff that you're doing at Caltech. So can you describe how you go about doing this and what are sort of the broader astrophysical implications of your work at MIT?
Right. Yes. Okay. Yeah. I'm happy to talk about that. Yes. So I think right. So when I was at Caltech, as you know already, I was working on a lot on nearby supernovae, faint supernovae, and we believe that a lot of these explosions, when they happen, so when you have two stars that are next to each other and one of them goes boom, it leaves behind in a lot of cases a remnant star, which is a dead star that's still floating around. These are, if the star is massive enough, it leaves behind what we call either as a neutron star, which are these extremely magnetized stars that have very small sizes, like of the order of the size of a city. And in the most exotic cases, they leave behind things that we call black holes, which I think there's a lot of excitement about black holes because we just don't understand them very well. So that was the focus of my research back at Caltech. But then I think it turns out that because of all of this new instrumentation that's coming along, especially in the infrared, we're really getting to this stage where we not only can find these neutron stars and black holes being born in these spectacular explosions in other galaxies, but we can actually hope to find the remnants of these explosions floating around in our own galaxy. So, a typical supernova, the kinds of things that I was studying, that happens of the order of once every 100 years in a galaxy like our own. So which means that if you wanted to do an in-depth study of supernova in our own galaxy, that we have to wait a few hundred years. But of course, we don't live that long. So what that means is that we can actually instead hope to actually look at the remnants of these things, like when, let's say, a supernova happened 1,000 years ago. I did not observe the supernova, but the remnant of that supernova is still floating around in the Milky Way. And those are the kinds of things that you could hope to find with things like infrared surveys, which has sort of been the focus of my work, which is that if you, because it turns out that there is so much gas and dust along, inside our own galaxy, it gets reasonably hard to find things within our own Milky Way when you're looking in the optical bands, the light that we see with our own eyes. I think the clear, relatively simple analogy is that, if you've ever looked at the sun during sunset, it changes color. It goes from being sort of yellowish in the middle of the day to being somewhat reddish near the horizon. And that's because there is gas and dust when you see the sun at the horizon. And the fact that it becomes reddish already tells you that the blue light that's coming from the sun gets preferentially absorbed by all of this foreground material, whereas the red light sort of just passes through and you see the red light. That's why it appears red. And the same thing we see everywhere else in the universe. If you try to look in our own galaxy, you see that all of the bluer light, the optical light that we see, gets absorbed by the intervening gas and dust. But the infrared light, that's the long wavelength light, which is red, infrared light, actually makes it, it's a lot easier to see things in infrared light. And so I think now that we are sort of entering this era where we can systematically look at the universe changing in the infrared, we can now finally hope to actually find many of these remnants that are floating around in our own Milky Way. And most of them would actually also be in binaries. We have a dead remnant of a star that's floating around another companion. And we can find these with infrared surveys. So that's the direction that my research has headed towards, which is that what I'm doing here at MIT is that developing new methods as well as using existing surveys to find evidence of these dead remnants of stars floating around other stars in the Milky Way, using a combination of the fact that when you have, like I was saying, when you have a companion floating next to a star, it affects the companion, and that's the kinds of effects that you can see in these infrared surveys. When you take pictures of the sky again and again, especially create a movie of the sky in the infrared, you can see effects of the companion on these systems, and we can hope to study them now with these upcoming surveys. So that's broadly the focus of my research now.
That's awesome. I mean, I never really understood why the sunset, it turns different colors, but now it makes a little bit more sense. But on my questions are definitely going to be more base level just because of my lack of astrophysics understanding. But could you explain a little bit more as to like why most stars are in binary systems? Like, is one formed before and then the other one starts orbiting around that, or are they kind of formed at the same time? How does that work?
No, that's an excellent question. In fact, I think it's reasonable to say that in a lot of cases it's an unanswered question. Like it's really at the forefront of research today. The short answer to your question is both. It really depends on where the star is when it was formed. But the idea is as follows, which is that I think at a basic level, we understand that actually most stars are actually formed together. So in the sense that when you have a binary star, there is evidence that these two stars were actually born together. They have always existed together. And the reason for that is rather interesting. I'm trying to think of an analogy there. But I think one of my favorite movies is this. You may have seen. It's called The Dark Knight, Batman. And there the Joker has a dialogue which says, I think goes something like, madness is like gravity. All you need is a little push. And that's really and that's really, I think, at the base of the reason why most stars are formed in binaries, which is the idea that if you think of how stars form, right? So when the way stars form is that you have a cloud of gas. So this is just gas that's floating around in space. Because gas has mass, it has its own gravity. And this gas, when you put a bunch of gas together at one place, it's going to, their own gravity is going to pull things together to become smaller and smaller. And at some point, it turns out that there is a critical mass scale that the astronomers call it the Jeans mass or whatever. And the idea is that when gas clumps together because of gravity, there is a typical mass scale where as the gas clumps, it tends to break apart. So imagine you have a ball of gas and you're putting it together. And then at some point it becomes so dense that because of the way the clouds form, instead of staying one single clump, it just breaks apart into two clumps. And you can show that happens because of the physics of it. So imagine, a gas clump that was going to collapse into one single star, very massive star. But instead of collapsing into one single massive star, it just broke apart and formed two clumps. And those two clumps will now individually go down and form their own stars. So because of the way gas clumps, it's almost natural to expect that instead of having a single star being formed from a gas cloud, you actually have multiple stars being formed together. And in fact, we see this directly when you look at nearby star forming regions, which are in our own galaxy. You always see these young baby stars forming in clumps of tens to hundreds of stars together. So there'll be very small regions of space where you see hundreds of newborn stars that are forming at the same time. And that's one of the reasons why this happens. So when you have so many stars that form at the same time, many of them will eventually end up spending all of their lives together. And that's how most stars are actually formed in binaries. So in that sense, our sun is a relatively outlier in the sense that it doesn't have a binary companion, because binarity or multiplicity, or the fact that the stars form in multiple systems, that's almost a natural feature of how stars form. So that's, I think, one of the reasons why stars are found in binaries. They're just born together. The other thing that you mentioned is actually a bit more interesting, and perhaps I think a bit more interesting from the theoretical point of view as well, which is the idea that you could have stars that are essentially born in isolation, and it just happens to be formed from a gas cloud that decided not to fragment, or because of other reasons, maybe the companion did not stick around. But if you have a region of space, so I was mentioning that that we know of these clusters of stars. So we know of the fact that gas forms stars in clusters. If you put a star in a reasonably dense cluster, in the sense that you put, let's say, hundreds of stars in a region of space that are that makes it extremely cramped in stars, you can have situations where even if a star was born in isolation, you have just another random star happened to be passing nearby and it gets captured by the gravity of the star, and the two start orbiting each other. And there are somewhat special regions in the universe where we think this probably happens the most. These are certain types of clusters known as globular clusters, which the idea is that these are extremely small regions of space where you can have hundreds, thousands of stars cramped into one region of space, all sort of bound together by their own gravity. And then you can have these random encounters where some unfortunate star happened to be passing by another star and got caught up in its gravity. And there is evidence that this clearly happens in the kinds of clusters that we see in our own Milky Way. So yes, the short answer to that is that yes, both happen. I think I think both are really at the forefront of research. How do we explain the multiplicity of stars using both of these combination of both of these effects that are happening in the universe?
That's awesome. That makes a lot of sense. And I feel like you explain things really well using analogies and things like that. So I can really absorb and imagine these little baby stars being born at the same time. So that's really cool.
Thank you.
You mentioned earlier that sometimes when these stars explode, they can create neutron stars, supernova, and black holes, things like that. But reading your research, you kind of refer to these events as cosmic fireworks, which I thought was really interesting. So how did you coin that term?
Oh, okay. I don't think I coined that term, to be honest, because I think so I think it started maybe, I think it was probably a few years ago when my advisor and me, we were having a debate about what the title of my PhD thesis should be. So I think a few years ago we were discussing ideas for what the focus of my research should be during my thesis, and it was, I think, immediately obvious at that time that I was really interested in sort of creating roadmaps for stellar binaries. Like I was saying, you start with two stars and then you let them evolve. What kind of observational phenomena can you use to constrain what these things do? And then we sort of realized that pretty much all that we were doing were actually looking at these extremely explosive transient events in the lives of these stars, and of the kinds that we can see as these brilliant flashes of light in the sky. So I think I think it was probably Mansi that came up with this. She would have probably been the one that injected this idea to say call it fireworks or something of that sort. But I think yeah, I mean, I'm pretty sure it started when we were sort of trying to debate what the title of my thesis should be. But yes, that's how that sort of that's the genesis of that idea.
Yeah, that's really cool. When I first saw your thesis, that was definitely the first thing that stood out to me. I thought that was a really cool name. Thinking of these events as fireworks, which is also the events that I also study, is a very cool way of like looking at it, I think. And I think I'll try to remember that. So now getting a little bit into your background. I know that you were born in Kolkata, which is a large city in Northeast India. So could you shed a little light into what the experience was like growing up there and how you eventually came to find astronomy as your passion?
Yes. Okay. That's a fun question. Yes. Okay. Right. So, like you said, I was born in Kolkata. So Kolkata is one of the four big cities, one of the four biggest cities in India, and it's on the. So okay. So I grew up in Kolkata, and I was born in Kolkata. My parents were from Kolkata, but so my grandparents were actually from Bangladesh. So that's the history of our family. So when I grew up in Kolkata, I was always this, I guess, since I was pretty young, I was always the nerd in my in my class, and I think the fascination for astronomy, I think I don't quite remember where it started, but I was just always fascinated to look up and ask, what's going on up there. And I think when I was very young, because I was interested in looking at the sky and trying to look for, I think a lot of it started with just reading books about constellations and about histories of constellations. And I say, constellations were really more of mythological things, when you said that hey, there's a thing that looks like a man with an bow or some animal in the sky. And I think I found those patterns really interesting, and I try to recognize those patterns, even though the sky in Kolkata is not the greatest because it's a city and there's a ton of light pollution and stuff. Yeah, so I think it went from being patterns to progressively, as I was growing older, as I learned more and more math and physics in school, that the interest in patterns really evolved into an interest in understanding sort of the physics of it. Why is that star red, or why is that star blue, or why are those two stars together? And especially once I think my parents were really happy with that interest, and they gave me this telescope when I was, I don't know, 10 years old or something, like just stare at the sky. And I used to take that telescope up to the rooftop of our house, and we used to I used to spend a lot of time just looking for red stars and binary stars. There are many naked eye binaries we can resolve in telescopes. So I think the interest went from the interesting patterns, which are just in the constellations, to an interest in understanding the very basic physics. Why is that star red and why is that star blue, or why are those two stars together in the sky? And of course, when you have a reasonably small telescope, you can start looking at things like planets. And I remember I was completely shocked when I first saw Saturn through a telescope. I was like, oh my God, I can actually see the rings of Saturn. Like that was like a completely a moment that I really realized that this stuff is real. Like it's not just pictures on the internet. It's just so I think that really fascinated me. The first time I saw the moons of Jupiter in a telescope, the rings of Saturn, or I think the phases of Venus. Like so when you look at Venus in the sky, it changes phases like the moon. Like sometimes it's half Venus, sometimes it's crescent Venus, and so on. And I think that stuff completely blew my mind when I was very young. So I think so eventually I think when I got into when I was graduating from high school, I realized that I had that interest in sort of math and physics at the time, and I was like, let me just go into undergrad in physics and see what it looks like. I think even when I was starting undergrad, I had this interest in astronomy, but it wasn't obvious to me that that might be sort of the thing that I end up doing, because I think at that time I was also reasonably interested in chemistry. For some time I was like, the chemistry also seems very interesting. I really liked chemistry even when I was high school. But so I think I sort of went in with this very broad interest in physics, chemistry, math when I was in undergrad. And as you go into undergrad, you do in your first year or so, you do all kinds of different courses, and that's when I realized, okay, chemistry is not for me. So and then that's I realized I'm more of a physics and math person. And then I think especially during the first couple of years of undergrad, I really started appreciating how you could use very simple undergrad physics and undergrad sophomore freshman year physics to explain a lot of the phenomena that we see in astronomy. And that really impressed me. The fact that these things are very far away, and these things are extremely big on scales that we can't even comprehend on Earth here, and yet you can use very simple physics to do that. And I think I think the beauty of that really struck me, and I was like, okay, I have to try something, doing some research in astronomy. And I think I did a few internships when I was an undergrad doing research in astronomy at nearby institutions in India. And yeah, I think that's really the story, which is went from patterns to this fascination to actually understanding the physics. I was like, okay, this is it. Like this, I love doing this thing. So and that's where I am right now.
That's such a nice story. I mean, when you were 10 years old, you were looking at binary stars, and you're still doing that now. So you really came full circle. But just a little bit more deep diving into your undergrad experience, how was going to an undergrad institution in India compared to what you see when you mentored students at Caltech, for example?
Yeah, okay. Right. So okay. I'm trying to think of the differences. Okay. So so I think the undergrad institution I went to in India, right, it's called the Institute of Science. And I think Institute of Science is a very well-known institution because I think it's one of the premier research institutions in India, which is, and what that means is that when I was doing my undergrad, I think similar to a lot of places here like Caltech or MIT, there's a lot of exposure to sort of state-of-the-art research. There are so many departments and so many excellent faculty who are doing really forefront research. And I think I find that part to be common between the institutions I've been at, or undergrads I've worked with here, and as well as my experience back in India, which is that I think there was this one common thread that I think you always have this exposure to ongoing research, which I think is great. And as an undergrad, I think especially I realized during my freshman and sophomore year that at that stage you don't quite understand all of the stuff, but you're really trying hard to make sure that you gradually learn. Back in India, I think it was quite interesting to just to slowly learn things as you grow up. I think especially in astronomy, you not only do you have to learn physics, but you also have to sort of get your hands dirty with a lot of coding, in the sense that you have to understand how to deal with data, because we're flooded in data in astronomy. So I think growing up, I think I really found the perfect combination of things to really get involved in all of this, and I'm really grateful for that. And I think looking at I think based on my experience with undergrads over here, I think undergrads here are smarter than what I was when I was undergrad. Like I've worked with some really great undergrads, and I think I've been really fortunate to get to interact with some of them here. And I think in terms of the differences, I think there's a lot more independence here and scope here to sort of do whatever kind of research you like, which I think is really a good thing about the education system over here, which is that if you're interested in something, it doesn't matter. You could be doing an undergrad in physics and doing your project in biology, and and vice versa. And I think there are lots of opportunities here to do that. And I think that the students here are also equally talented to sort of try to do a lot of different things at the same time. So that's been my experience. Yeah.
Yeah, that's really interesting to hear your point of view on that, especially being Indian, but not growing up in India, but hearing how like my parents talk about how their time was in college there. It does seem to be very different than sort of like how the system is here. But yeah, so that's really interesting. Now getting into your move from India to Pasadena. That's a very large one on many levels. So I was wondering how you could sort of talk about the move, and like how you dealt with being so far away from home, especially like your first couple of years of grad school at Caltech.
Right. Yes. Okay. That was like, I think going to grad school was I think very broad. It was not only like a complete new experience academically, but also sort of culturally and socially, because this was the first time I was living outside for a very long period of time outside India. So I think before coming to Caltech, I did spend some time abroad. So when I was in undergrad, I spent a few months in Germany. So I was doing an internship in Germany. So again, Germany is a very different country than the US. But I think the first time I actually visited the US was when I was a prospective grad student at Caltech, and that was my first ever trip to the US. And I remember that being quite a surreal experience. Like you're transported to a different universe altogether, which is quite fun. I remember like when I first landed at LAX, and there's this other grad student who drove me from LAX to Pasadena. I was shocked with how fast the cars were driving on the freeway, because you're not used to seeing that in India, at least. But yes, so I knew I was going into an interesting territory over there, both academically and culturally. But I think the first year at Caltech, I was really grateful, because I think even though it was quite a big transition, socially and culturally, I think I had an excellent cohort of students who were sort of in similar situations, and some were of course from here, and I think I think they helped me navigate the society and the culture here, without which I wouldn't have sort of figured out how things work over here. Because I remember like some of my classmates, we still talk about these stories about how naive I was about how things work over here. Like I had never been to a grocery store in the US, and I remember when when I was in my first year of grad school, we used to always, the entire class used to drive together to the grocery store to buy stuff. And I think I really learned a lot because of those, having that cohort. But yes, I think, so yes, in terms of the experience, I think it's definitely a big social and cultural transition. And I'm grateful that a lot of my peers at Caltech sort of helped me navigate that transition. And of course, I think initially I would say that maybe the first couple of months, it's all excitement and everything, seems like, you're in the new universe, you can do whatever you want and so on. But I think, like you said, eventually at some point, that thing also hits you that you're really far from home. So I think it takes, so to go from, from LA to back to my hometown, it's about a 23-hour flight, which is not the easiest to do, and also it's not cheap because it's a very long flight. So going home, I think eventually you realize that going home is not something that you would be able to do very often. I think like when I was doing my undergrad, I was still living in a different city. So I was doing my undergrad in Bangalore, compared to which is in South India, compared to where I live, which is in Kolkata. There's sort of a 2-hour flight away. But here, when you transfer it to the other side of the planet, it's literally the other side of the planet. I think then it becomes obvious that that doesn't happen very often. So I think there were definitely periods of time where I missed being at home, in the sense that I think as many of you would know, India is very rich culturally, which means that there's lots of every week there's some festival going on, some this and that and so on going on, and you start missing those things, especially during the times when they're happening, because I would open Facebook or something, and I would see all my Kolkata friends, enjoying some festival, something going on over here, and that I would obviously not be able to be a part of that. So that was so I think that does hit you at times, especially early on, because you really miss that. But then I think again, because I had, I think, an amazing set of classmates at Caltech, I tried to import some of those experiences to over here. Like I would pull them with me, like, let's go to this place which is 50 miles away, but they're doing this festival that I really want to be a part of. So a lot of, because there is such a big presence of Indians in the US and even in the LA area, like you could probably find within a 50-mile radius some place that's actually doing the festival that you're interested in. I used to pull my classmates to go along with me, and that, I think that helped navigate some of those feelings that you get of missing out and so on. But yes, so I think that really helped. And eventually, I think as years as time progresses, you eventually get used to this thing of being away. And I think then I think you start cherishing the moments that you do spend with your family, because I'm probably with my family, I would say maybe 3 weeks in a year, and I think there's so much excitement that that you get when you're planning those trips. When you're planning those trips, when you're sort of getting close to those trips, and obviously while you're on those trips. And I think it makes you realize sort of the I think it definitely makes you realize sort of the importance of being with family, and the kinds of and how you should sort of make every moment count when you're with them. So I think that sort of summarizes my speech. Is that obviously there's initial phase of this feeling of missing out, but eventually you learn to navigate that, and you really start appreciating and cherishing the moments that you do get with your family back home.
Yeah, thanks for sharing all of that. I think that's really good, like almost advice, especially for any international students who are entering grad school for the first time. I think that obviously I have no idea how hard that experience is, because I grew up here my entire life, but just hearing you talk about it, it seems like a really difficult transition. But I'm glad that you had people around you that really helped you make that, and it was like good for you, and you're able to succeed at Caltech for sure, immensely. A question I wanted to ask you on sort of on a personal level, because I went to Caltech for undergrad, is how you feel about how graduate school was there as a student. Because I have my experiences there as an undergrad, which were definitely very difficult, especially because I also played basketball. But I wouldn't trade it for anything because of the experiences I had and all the research that was available to me. But I've heard very different things about being a graduate student, about how life is like there. So sort of how was that like, I guess.
Yeah. Oh yeah, sure. Yes. Yeah, I think so yes, I think when you start, at least, so I can speak for the Caltech astronomy department because that's been primarily my my exposure to Caltech, and it is true that so the grad program in Caltech astronomy is set up such that the first year you're going in, you're sort of supposed to do all of these courses, which is which teach you some of the most basic things about astronomy, because many people come in with different backgrounds. So I had an undergrad in physics, somewhere someone else might have a different background. So it's important to sort of keep that to have that common set of courses so that everyone comes up to speed with at least the basics of astronomy in all the fields, and those courses can be tough in the sense that it's a lot of material to digest given in those first 3 quarters that we have at Caltech. So but I think having said that those courses do have a lot of material and can be quite grueling. But there again, I think your cohort is so important in all of that, because I think some of the even during my first year at Caltech, some of the times when my class as a whole we bonded together was during solving homeworks for those courses. Like we would spend nights in the department solving homeworks together and just enjoying that experience, and we would discuss the questions, how to solve questions and all of that. So I think even though the first year of grad school can be somewhat intimidating because the course load is really heavy, I think that also gives you the opportunity to both learn and sort of and bond with your classmates at the same time. And I think that was a really rewarding experience for me at that time. And I think going ahead, once you go beyond first year, that's I think towards the end of first year is when most people start taking up small research projects. And there I think it's very important to sort of to choose your advisor, right? Because I think your advisor, they should, you and your advisor should be on the same page about how things are done. There's a working style and so on. So I think I was really lucky in that. I think Mansi has been so such a great experience in the sense that I think we've always had such amazing conversations about science and sort of life and all of that. And I think it's so I would say that a lot of the graduate experience at Caltech was both about being able to sort of navigate that first year, which is, and also make the most of it academically and enjoy it, and also eventually in subsequent years choosing the right advisor. I think it's very important to make sure that you and your advisor are agreeable to your working styles, to your ideas, and so on. And I think I was really fortunate in that aspect.
That's so great to hear that you had like such a strong sense of community within your cohort. But in regards to Mansi, Professor Kasliwal, how did she end up becoming your advisor? Did you guys just know that you would work well together? And do you think that it kind of helped that she was also from India and she had the same experiences as you growing up?
Right. Yes. Okay. That's another funny story actually, which is that when I was in undergrad, I actually didn't do anything of the kind that I do right now. So when I was in undergrad, a lot of the research projects that I had done were actually in this field called radio astronomy, which is it's different from sort of the conventional astronomy that we think of in the optical, in the sense that you use these gigantic dishes of that just gather radio light rather than optical light. So radio light is the kind that you see in your cell phones, the kinds of stuff that your cell phones receive, but you're trying to detect this from astronomical sources rather than in satellites or anything. And the techniques there are very different. So when I actually first applied to Caltech for grad school, I wanted to do radio astronomy. Like that was my entire application was about radio astronomy. I don't think I'd interacted with Mansi at all before I went into grad school. So so I think it's only after I arrived at Caltech when we had this. So at Caltech we had this. With some sort of seminar course that you take in your first year, where all of the faculty give small presentations about their research. And I went to a presentation that Mansi was delivering, and I was like, wow, okay, this sounds very interesting. Like obviously I at that time I really wanted to do radio, but I was like, it's my first year at Caltech. If there's any time where I want to learn a field that's different from my expertise, then I should do it right now, because this is grad school and this is the best time to learn things. You have all the time you like to learn things. So I think at that time I was like, let me try and do a small project and see what it's like in a field that's completely alien to me. Like I knew nothing about optical infrared at the time, and that's how I saw Mansi's presentation. I was like, this is great. So I went to Mansi and I said, can I do a research project with you? And so that's when so we sort of started working together. We had this I started working on these individual events. So these are essentially individual flashes of light that were discovered at that time, and started interpreting some of that data. As part of that process, of course, you have to learn sort of all the tricks of the trade, how to analyze data, how do you interpret data, and how do you fit models to data, and all of that. So I think that's how it started, which is that I just wanted to do something different from what I did in undergrad. And Mansi was, when I heard Mansi present, I was like, this is great. Like this is really very different from what I am, and also is at the forefront of what's happening in this field today, which was time domain astronomy. So it started with that, and then I did a couple of small projects with Mansi before I decided that I wanted to really take that to the level of a thesis. And that's how I got involved in these bigger time domain surveys. So I initially started with small projects that were looking at individual events, but then now that as we were deciding for the thesis, I was like, now we can actually extend this to much bigger projects. Things like these time domain surveys that were running at Caltech. Initially, this Wiki Transient facility, which is this big optical survey that runs at Palomar Observatory, and then take it to the next level and say, hey, I want to build my own time domain survey. So that ended up becoming Palomar Gatinia, which is the subject of my thesis. So yes, I think that's how it started. And I think during that process, I think there were definitely moments where the Mansi being from the same background as me. I think Mansi grew up in India, and we sort of had the every now and then we would share that common thread, in the sense that we would talk about experiences back in India, nitty-gritties about Indian culture and festivals and so on. In fact, I would think that maybe this is right. So this is actually relates to the question that you asked earlier about this thing about fireworks. I think that maybe the genesis of that idea might be somewhere when Mansi and I were discussing about Diwali. So Diwali is this festival back in India where it's a festival of lights. People like doing fireworks and stuff. And I think there was some exchange of emails at that time where I think we were just joking about sort of how we found this transient, I think somewhere very close to Diwali, and like here is a fireworks for Diwali or whatever. So I think that might have been the genesis of that idea. I'm not sure. This is I remember us exchanging emails along those lines to say that, hey, we found the fireworks during Diwali or whatever. So yes, I think there were definitely a lot of fun experience that we had because we shared that common culture. And I think even further down the line, I think there were times when I think during grad school is hard. Grad school is hard, both academically and as you grow up, there will be situations in your life which will be personally difficult for folks. And I definitely went through some of those situations that were personally difficult for me. And I think in a lot of those cases, I think Mansi really understood the depth of many of these situations. So stuff that has to do with family and personal situations and so on, because of that common background. So I think it was. I'm really grateful that we had that common connection, that I could actually explain something that was sort of somewhat specific to my cultural background and somewhat specific to how the Indian children grow up and so on, and share that, and someone would understand that and sort of have solutions that are or at least have solutions, advise you based on having that common understanding. So I think that was extremely helpful, especially during the times when you go through these more difficult times personally.
Yeah, that's amazing to hear. I also have a very similar experience with Professor Kasliwal as my advisor. Even when I was going through some tough time personally, she really made things easy and was very understanding. And I definitely have done my best research ever up to this point with her. So she's a great advisor, and hopefully we'll get her on the show soon. So now talking a little bit more about being an international student at Caltech. Were there any barriers that you felt sort of because you are an international student there at Caltech?
Barriers, huh? Okay. So yeah, okay. So I guess I can. Okay, so okay, I think as you would probably know this, I think there. I think compared to other schools in the US, I would think Caltech has the barriers would be somewhat less evident because there's such a huge international population at Caltech. Like I think that makes things so much easier in the sense that I remember when I first went to Caltech. Caltech has this international students organization or something of that sort. And I remember during the first month that I was at Caltech, like they had this events all the time because they really wanted to make Caltech welcoming for international students, and there's a big population of international, even graduate students at Caltech. So I think so that definitely helped navigate some of those barriers in the sense that so I was telling you about these cultural differences, right? I remember at the internet, so when we were going through this international student orientation, like there would be sessions where they would be like, this is what it means when an American says this, and this is what it means when an American says that. And I didn't realize, I grew up watching a lot of American TV shows, but even at that time, I didn't realize that I didn't actually understand some of those phrases. So I think that definitely helps remove some of those barriers. But I think so I can't think of any specific Caltech related things that were barriers as an international student, because I think a lot of the team at Caltech really did their best to sort of make this a welcoming experience for all international grad students. But I'm trying to think if there's any individual experiences. Yeah, I guess did you want to know more about the barriers as an international student at Caltech, or like in general?
In general too, yeah.
Oh, okay, right. Yes. So I think, yeah, I guess I'm not too can't think of any. Well, I already mentioned this thing about staying away from home and all that, but I think because of this big presence of international students at Caltech, I can't, I think overall the experience was very rewarding. Like even though you are staying far from home, and as you go through the process, you learn more and more about how American culture works and all of that. Yes.
Well, that's a really interesting perspective. I mean, I'm obviously not an international student, and I don't know how the population was at Caltech, as I didn't attend there. But could you like compare your experiences at Caltech to how you're feeling at MIT right now? Are there any like similarities or differences that stand out in like respect to the academic culture as well as the social culture and the way that they like treat you as an international student? I mean, Caltech did a lot of things to help, but is MIT the same way?
Right. Yes. So this is I always I used to when I was at Caltech, I used to really laugh a lot hearing about this weird feud that exists between Caltech and MIT about how undergrads and these two institutions don't like each other. So I was very curious to know how that works, but then I realized it's only the undergrads. Once the graduate students and faculty don't get, it's a very undergrad thing. But I think I found that quite funny that there's this weird feud between these two institutions at two opposite coasts of the country. But yes, I think moving from Caltech to MIT, I think MIT is a bigger university. There are many more students over here. And I think during my my experience at Caltech, with the smaller population, I think the thing that I really liked about Caltech is that in the astronomy department, it was just so small, yet so many things happening that that almost everyone knew everyone else, and you could say hi, you could go for lunch, coffee, whatever. It's anyone you like, and you could just strike up a conversation because it was a small department and there's so many things going on. There's a lot of people to talk to, and pretty much anything you want to talk about, because someone or the other is doing some cutting edge science somewhere. I think it was really rewarding in that sense. And I think moving to MIT, I think that's that experience has almost remained the same, which is that I think MIT, the astrophysics group, is also there's so many things going on, and because again it's a small department, it's everyone knows everyone else, and you can pretty much strike up a conversation about anything you want. And I think that's the common thread that I see between Caltech and MIT, which is that the fact that these schools are both of these departments are relatively small. You know pretty much everyone else, and that really helps having this sense of community, and also sort of having all kinds of interesting discussions about science and so on. So I think I guess the thing that I haven't experienced personally is how it is like to be a grad student at MIT, because I've been here as a postdoc, and the experience is somewhat different in that. I think the thing that is obviously not specific to MIT, but is that I think your community as a postdoc is different from your community as a grad student, because as a grad student you always come in with this cohort of people who are sort of at the same stage. They're all sort of in this stage where they're all figuring out, trying to what they want to do with research, what they want to do with life, and so on. And as a postdoc, I guess as a postdoc, you sort of you're expected to have some level of independence, in that you pretty much have a sense of what you want to do, and you have the skills that you need to do that. So I think postdoc life in general is nothing specific to MIT. Is that you are a bit more independent, and which also means that there isn't sort of a common cohort that you sort of work with like in grad school. But I think even in that aspect, I think MIT is really welcoming, has been really welcoming to postdocs. I think especially during the time that I came in. So I started in MIT like in the middle of the pandemic. I think this was summer of 2021. So that's not the easiest time to start at a new position when you're moving cross country and settling into a new place. But I think my mentors at MIT have been incredibly helpful in sort of helping navigate that that experience, because it can be hard. You're sort of, not only are you at a new place, you pretty much don't know anyone, and then you're isolated. So so that can be pretty grueling if you don't have the right set of people to mentor you. And I've really I'm grateful for that experience, and that I think the seniors at MIT really appreciate the fact that the incoming postdocs have seen MIT in a very different way compared to what it was prior to the pandemic, and they're trying really hard to sort of to make it still rewarding for new incoming postdocs, because this is being a postdoc is, I think, probably one of the most fun phases in this academic trajectory, because you have the ideas, you want to do fun stuff, but you also want to be in the right group of people who will sort of help you nurture those ideas and do amazing science with it eventually. So I think so my experience has been that MIT has really done that part in trying to make postdocs feel welcome, and also sort of develop this sense of community where you could pretty much go up to other postdocs and say, hey, why don't you try this, why don't you try that, and all of that. So so yeah, that's been my experience so far. And I think all of this is because, again, MIT is the astronomy group is not very big, so it's there are many opportunities to pretty much strike up a conversation with anyone on any topic.
Yeah, that's really interesting to hear about the differences in some ways between the two places. I can definitely tell you that there is a rivalry within the undergrads. When I went to MIT for my official visit for basketball, some of the students there told me not to go to Caltech because people there are lame, which which, well, coming out of Caltech, I don't agree with. So, because I had a really good experience there with the people that I met there and the friends I've made. So, but yeah, a rivalry is definitely there on the undergrad point of view. So it seems to me like you're getting so many things done all of the time, because all the research projects you're doing, all the students that you mentor, and you're involved in so many different projects. So how would you take time for yourself outside of research? I know that you are an avid biker nowadays. Is that an interest that you sort of recently found?
Yes. Okay. So right. Yes. So it's very easy to keep yourself busy with academic work all the time. I think there's enough data out there, enough things going on out there, that it's very easy to get sucked into work and keep doing that all the time. But I've started appreciate. I think that's somewhat of a recent phenomenon. I think that really grew during the pandemic. That it's very important to take time out for yourself and do things that are outside of research, and the things that keep you both mentally and physically active. And that I think I started realizing that more and more during the pandemic, where you were sort of locked inside this house and not doing much outside of watching TV or doing whatever is required to doing your research and stuff. And the thing about biking is that actually pretty much came out of the pandemic, in the sense that I was I think all of us were stuck at home with not much to do, and we didn't it was the safest option to stay away from people. And then the thing that I realized was that if I wanted to be outside, if I really wanted to explore the areas around Pasadena while also not sort of hanging out with people, I think I realized that biking was a really good way to do it, which is that so what I think this started really in the middle of the pandemic, where I was pretty much doing nothing at home. I was like, I can't do this for I don't know however long this keeps going, so I need to go outside and start doing stuff. And that's when I picked up biking. So what I used to do is that I have this apartment in Pasadena, and then I used to bike from Pasadena to downtown LA, which is actually not too much. So it takes about maybe something like 40 minutes or something. And there were a lot of these amazing bike paths in LA, and something that I'm really appreciating and missing right now is how good the weather in LA is all the time in the year, which I don't get it here anymore. So it's almost always perfect outside for biking or running, if you like. That's that because the weather was so good, and there were these bike paths that went from Pasadena to LA. That's what I started doing. And I used to just every evening I would just finish work and actually take off for a couple of hours and go to downtown LA, have some food at some some restaurant over there and come back after dinner. So that started becoming my schedule. And then I think as I got better and better at biking, I started doing more adventurous trips. I would go from Pasadena to Long Beach, which is very far in the south. So either Santa Monica or Long Beach, and I used to bike all the way. And it turns out that there are these really nice bike paths that go from close to Pasadena all the way to Long Beach. There's the Los Angeles River, and the Los Angeles River on both sides has bike paths. And those bike paths, there are no cars on those bike paths, so you don't have to worry about getting hit by a car. And then you can just bike it takes, I think, probably used to take me maybe 3 hours to get from Pasadena to Long Beach. That's about, I think, 30 miles or something. But I just enjoyed that part of the weather was always perfect outside, and I was biking along the things, and that also helped me I think during that last year when I really picked up this hobby, I saw a lot of places in the LA area that I would not have seen otherwise, because why would you go on a bike path if you're not biking? These bike paths actually go through a lot of interesting neighborhoods. There are lots of interesting restaurants that I would probably not even realize. I think as someone who's lived in LA, I think you probably realize that LA is like so big, like it's nearly impossible to know the entirety of LA because it's so spread out and so big. And unless you have a reason to go to a specific neighborhood, you wouldn't actually go there because it's so big. So I think that was a really interesting experience to sort of go to places that I would not have otherwise gone to, and see neighborhoods and just navigate the area. I think Pasadena, because it's on the foothills of the mountains. I think the other thing I should like to do is just bike up the mountains, which is a lot more grueling because it's hard to bike up a mountain. But by the end of it, I think it's very rewarding because the views are really nice. I used to bike from Pasadena in the evenings up to somewhere up to the mountain, and then you could see the lights of LA from that place, and that was really nice.
That's really impressive. I don't know how to ride a bike, so I can't even imagine going up a mountain, but I'm sure the views and the experiences were worth it. And it's really nice to hear that you look back at your time in LA fondly now because of this new hobby that you have. So that's great. But now we're just going to talk a little bit more about your future.
Yes.
So ideally, like, what do you want to do? Do you want to be like in academia? Do you want to be a professor or work in industry? What would you like your perfect scenario be?
Right. Yes. Okay. That's a fun question. Yes. So okay. So if everything goes according to the way I would like it to go, I think I'm really looking forward to a career in academia, in the sense that I would like to be in a stage where I can eventually go into a faculty track position and actually teach students to do stuff. I think based on the limited number of amazing undergrads I've worked with, including Gokul, I think there's nothing more rewarding than seeing a student do something and come up with ideas that sometimes I'm like, I would have never come up with this idea. So I think it's been really rewarding to with that limited experience to be able to mentor students and teach them to do things that even you probably wouldn't have thought of. And so yes, in the ideal scenario, I would like to take that forward, and sort of I see that as a very appealing career to me, which is doing research, but not only doing your own research, but also inspiring younger people to do research, and initially with your own ideas, and then of course then inspiring them to build their own ideas and then take it forward. So so yes, that's sort of the direction that I'm hoping things will end up in.
Yeah, that's amazing. You're definitely on track for that. If there are any faculty watching this, just know Kishalay would be an amazing person to have in your department. He's going to make your department 1,000 times better. So just putting that out there. So yeah, so on the topic of mentoring students, you've been a research mentor for quite a few students already, and you're definitely very good at it. So in the future, do you see yourself continuing to keep mentoring a really important part of your career, especially are there any specific groups of people that you sort of want to help guide through the academic sphere with regards to like the students that you're mentoring? And I was also wondering, what are sort of the strategies you use when mentoring students? Like, what does it take to be a good mentor?
Okay, yeah, right, yes. So yes, so I think mentoring, I found mentoring students really fun and rewarding, in the sense that that I think part of the reward of mentoring students is that I think I've had such amazing insights into things that that I wouldn't have thought of. I think because especially when you mentor students who come from, let's say, different backgrounds, it's like someone might be a major in computer science, someone might be in chemistry or whatever, and I think everyone brings in their own unique perspective of looking at a problem differently from the way I look at it. And I think that's been really rewarding, in the sense that I think I've definitely sort of modified my views of how certain topics because of the way I've heard students talk about it, because they come with their own perspectives and looking at things. In some of those cases, like I used to be like, wow, okay, I wouldn't have realized that there's actually this connection between this field that I had obscurely heard of in chemistry and this field, the stuff that I'm doing. So I really like that aspect of being able to sort of make those connections, because I'm exchanging ideas with someone who's from a completely different background. So yes, I hope to keep doing that. I think that's really been rewarding, and I think that that's been a fun experience. And and I hope to continue doing that. In terms of what's been the correct strategy, honestly, I'm still figuring it out. I'm still early on in this process, so I don't have any. I guess so far I've been taking it on a case-by-case basis. Like I just, I think it varies a lot. So from student to student, in the sense that, I think initially I would just like, say, hey, this is what I do, and this is there are certain set of basic principles that you can probably start talking with any student, and then you sort of see their response and see how they're responding. In a lot of cases, I think it's very common for anyone to try to make connections between what you're learning is new and with what you already know. And I think I try to be sort of especially receptive to those connections that they're making. And if I see a student trying to sort of, maybe someone has a good background in signal processing, and they want to make connections between what I'm doing and signal processing, I try to reinforce those connections, because I think it's always I think it's always easier for anyone to learn a new thing if you see some level of familiarity with the existing topic. And I think that's at least one of the things that I keep an eye out for, which is that if I see a student that is definitely going into new territory, because they've never done astrophysics before, but they're comfortable with sort of thinking of this astrophysics problem as a problem that they already understand, I try to make those connections, even though I probably don't understand that particular topic very well, but at least with whatever limited amount of knowledge that I have. And of course, then of course I think once the basic connections are made, then I think it's easier to sort of let the student decide how to take this problem forward. If they like approaching this problem in a specific way, just take it with the specific direction that you're thinking about. And I'll be there in more of an advisory capacity, saying that, hey, have you tried this or have you tried that, and and is there a connection that we could make, or how could you take this approach that you're using to some quantifiable results. And you can do your approach whatever you like, whatever you're comfortable with. But I think then eventually it becomes more of an advisory role.
That's good advice. I know Gokul wants to go into mentoring, so I'm sure he'll take that into account, especially as he goes through grad school. But now we're unfortunately coming to a close of our interview, and we just wanted to end off with some quick hitter questions. So I'm gonna go first. Could you tell me the 3 weirdest things that stood out to you about Los Angeles?
Okay, I can probably tell you 30 things that for Los Angeles. I think part of that is right is because I noticed a lot of the weird things, because that was such a big transition from going from India to LA. Okay, so let's see. Number 1, why are the blocks in LA so long? Why does it's not a very walkable city. Like you always have to be in your car, and that's what most people are doing. So I think that's definitely one thing. Let's see, LA food. I wouldn't say it's a weird thing, but I really enjoyed the diversity of food in LA, because I think there's just so many different kinds of cultures living at the same place, and I think that was really interesting. So I wouldn't call it weird, but I think it was really a peculiar thing that I'd actually never seen before. Like so many different kinds of restaurants, so many different cuisines at the same place. Yes, and third is lack of public transport, which is I'm seeing the differences now that I'm in Boston, which is that it's pretty much impossible to go from anywhere to anywhere in LA unless you have a car. And there is a train system, but yeah, it hardly connects in any of the places you want to go to in LA. So I think many places on the East Coast are somewhat better connected in terms of public transport, which is and I hope I don't know if it's heading in that direction, but there's definitely scope for having more public transport in the West Coast.
Yeah, those are all really good ones. Next one is top 5 Indian foods. I'm very interested in this one.
Okay. Okay. Right. So I grew up eating a lot of fish because West Bengal, which is the state I grew up in, so my native language is this language called Bengali, which is spoken in Bangladesh and eastern part of India. So I like fish a lot. So let's see. So fish dishes. So I love shrimps, and I think anything with shrimps is good. Let's see. Indian food. So okay, so there's a specific kind of shrimp curry that I really like, which involves essentially frying shrimp and then cooking it with yogurt and I think mustard oil, and there's quite an interesting combination that you can do. So I like that. Then of course in chicken, I love chicken, and I let's see, what would be my favorite chicken dish? I think my favorite chicken dish would be I think I like butter chicken. I think many of you would have had butter chicken. I think butter chicken is delicious. It's not the most healthy food, but it's delicious. And let's see, third would be so okay. I don't know what's it called, but there's this dish called puri in India, which is actually fried. Again, Gokul, is there an like an English of puri? I don't know what it's called. It's probably just puri.
It's probably like
Uh-huh.
it's kind of like a crepe, I guess. It's like fried.
Okay. Yeah. Okay. Okay. Yeah. Okay. Yes. Okay. So I love puris. Yes. Biryani. I'm an absolute biryani monster. Like I love biryani. So sweet dish. I have to mention sweet dish because I love sweets. Sweet dish. So I really like gulab jamun. Like gulab jamun has been my all-time favorite. So gulab jamun, and probably there's this Indian ice cream called kulfi that I really like. I think it's like more pistachio flavored, but it's amazing. That's been just my favorite desserts.
I think you got all the most important ones in that
Okay.
list.
Okay. Yeah.
Pretty solid. So the next quick hitter is there a new survey like Gatini or ZTF, a new upcoming one that you would want to be a part of?
Oh yeah, of course, yeah, so many. Yes, I think in the next 5 years, right? I think astronomy is really heading in this direction. There's just so many surveys coming online, and all of them are unique and have their own amazing data sets. So I think I probably in the next couple of years, I think the Rubin Observatory, which is going to do the legacy survey of space and time, I think that's really going to change our view of the universe. And I think I'm really excited about what Rubin does. And it's going to be primarily in the optical, but it's also going to have some near infrared coverage, which I'm really excited about. And then maybe I think a few years down the line, there'll be the Roman Space Telescope, which is again going to essentially going to be the Hubble Space Telescope with a field of view that's 100 times larger than the Hubble Space Telescope. So imagine not only getting these individual galaxies, but many galaxies at the same time inside the field of view. So I'm really excited about that. So those are I think two big survey instruments that I'm really excited about, and there are a lot of individual projects that are happening over the next 5 years. That I think these are mostly smaller telescopes with very focused instruments, but to name a few, there the ZTF is obviously is still running, and I hope to be able to use some of that data in going into the future. And there are a bunch of these near infrared surveys that are coming online again from the ground at various places on the planet: Australia, South Africa, Chile, and so on. And I think there's a really exciting time coming up in the next decade for time domain astronomy.
Yeah, so kind of continuing on that note, what are your top 5 favorite astronomical objects?
Oh boy, okay, that's a hard one. Okay, top 5 favorite astronomical objects. So I think something that I've learned is that a lot of the times the nearest one of any kind of object is always tends to be the one that teaches you the most about that object. And so maybe I can tell you the 5 nearest ones of the kinds of objects that I like. So let's see, the nearest black hole, I think the nearest undisputed black hole, there are some other claims, but the nearest undisputed black holes is actually in a system where you have a companion that's interacting with the black hole in this thing called an X-ray binary. So I think that's this system called AO620 minus 00 or something, which is which was discovered in the X-rays many years ago. So that's, I think, is still the closest undisputed black hole. Let's see, the nearest neutron star is this object called, it's a phone number, RXXJ18 something, and it's one of these neutron stars that were discovered back in the 90s by the survey called ROSAT. So yes, that the nearest multiple star system is actually the nearest stars to our sun is actually a multiple star system. This is the Proxima Centauri and the two Alpha Centauris. Yeah. I mean, as you would guess, if binary stars are common, the nearest star that we know of is actually a binary star system. So that's the nearest binary star. The nearest supernova, I think. Yeah, it depends. Depends a bit on what time period you're considering. Like there are probably some claims of a supernova going off in M31, which is Andromeda galaxy, which is the nearest galaxy going off back in the I can't remember the name, but I think the nearest supernova in modern history is 1987A, which went off in the Magellanic Clouds. And let's see, what other type of object do I think about? Let's see. I covered neutron. The nearest white dwarf. That's actually a good question. What is the nearest white dwarf? I have to look this up. I forget. Anyway, I guess. Anyway, whatever the nearest white dwarf is. Yes.
Cool. Yeah, that's definitely not what I expected to hear from that answer, but that's a cool way of thinking about it, because I guess it is true the nearest things do tell us the most about the universe. Hopefully we get a supernova in our galaxy during our lifetimes. That would be a cool project.
Will be the best place instrument to find it, because it will be buried in the dust.
Yeah, definitely. That would make Gatini very famous. That would be really cool. So yeah, we are out of time, but thanks, Kishalay. That was amazing. We really appreciate having you on as our first postdoc, and I learned a lot just in this hour of talking. And I'm excited to keep on working with you in the future and to look at all the amazing science that you do.
No, thank you so much. Yeah, I think these questions are very interesting. Like they really made me think about what my experience was, back as a grad student. I think you always sort of, I think as a grad student you're always trying to just survive and make sure that your grad school is hard. So, but I think it's good to reflect on some of those things. And I think some of those questions about science, especially, I think trying to explain astronomy to someone who's obviously who doesn't have the background in astronomy, I think that's one of the most fun experiences, because I think astronomy is one of those rare fields that I think intrigues almost everyone. Like everyone's looked at the sky and thought, what is up there? And I think it's really fascinating to sort of try to think of astronomy in sort of the broader picture of what it means.
Yeah, I never would have thought someone could compare the Joker to astronomy. So that was a really interesting way of how you explain things, and it really goes through nice. So I think that you are a great mentor. I already learned a lot, and I really appreciate you coming on. It was so nice meeting you finally. Gokul always talks about you very highly, so you really delivered.
Thank you so much. Yeah, and thanks for doing this series. I think this is great. I think I think it's very important to let everyone know about sort of the diverse backgrounds that people come from, and how everybody has their own experience, and especially like if you it's important to sort of highlight the different experiences that people bring into this field, and how those different experiences sort of make this field so much richer than what would be possible otherwise.
Definitely, yeah. That's an amazing way to put it and a great way to end. So
yes.
thanks, Kishalay. Appreciate it.
All right.
Thank you.